we'll be talking about kind of the dual nature of nitric oxide and how to make sure it's balanced. So the first webinar this year was on fitness. We talked about exercise and some of the health associations with that. Nitric oxide being one of the mechanisms whereby exercise is beneficial. I then went into part one of the nitric oxide webinar where I was talking about nitric oxide, the enzymes that affect it, metabolites associated with it, some genetic variants in eNOS enzymes. Well, actually, there's several types of nitric oxide synthesizing enzymes. There's particularly genetic variants in endothelial nitric oxide enzymes, which affect nitric oxide production. So talk about that, talk about factors that will be impacting that as well, and then ways to naturally boost nitric oxide. So that was the conversation last week. This week, I'm going to be talking about nitric oxide from a little bit of a different angle in terms of there's the nitric oxide, there's an oxide component of nitric oxide. So how can that not be good? How can that be in excess and what to do about it? Other enzymes that are playing a role in that. I've not seen this content anywhere. I mean, clearly there's research on this information. I've just not seen this discussed clinically. If I have, it's been scant or rare. So it's dense, so bear with me. But it's good stuff. So we'll be definitely getting into that in a little bit. I'll be back in 1 second. As a naturopathic doctor, I do all sorts of weird stuff. And I don't know if anyone has ever come across these Olbas inhalers. It's this little inhalation thing that contains menthol and peppermint and eucalyptus, and it really perks you up. So you twist off the nozzle, you close one sinus, you just breathe it in. It stings a little bit, but it wakes you up. This is Olba, O-L-B-A, O-L-B-A-S, Olbas. I don't believe it's a US company. I believe it's from some European, even though it's manufactured in Philadelphia, actually. Wow. Yeah, I love doing it, especially during the winter. Not that my sinus isn't congested, but it just kind of wakes you up a little bit. But they actually make a bunch of things. They make cough drops. I'm not affiliated with them any at all. I'm not affiliated with any supplement companies per se. I'm obviously affiliated with Ethereum, but yeah, no, I do like their products. They make teas and stuff. Yeah, is the citrus oil. Well, they've actually done studies with some essential oils, particularly rosemary oil. When I was in naturopathic school, before exams, you would see the students with like rosemary and they would be like rolling it up and just like smelling it right before an exam. And it's not like one student, like there was whole swarms of students doing it. And yeah, and even just the rosemary oil, but it's been studied to increase parasympathetic activity, but then also alpha wave brain activity. It's essential oils are very powerful. I am a big fan of them. It'd be nice if we, maybe we could do a webinar on it more in depth at some point. All right, so let me go ahead and share my screen. By the way, one other item I almost forgot. So I work for the company Ethereum. We have a metabolomics test that looks at metabolites, makes health associations from it. We also have a microbiome test. In ordering the test, I've had made aware to me, well, not made aware to me. We in order to buy the test, you have to buy it through us. It's not available through other third-party websites like Rupa. And if you are familiar with Rupa, it's basically a laboratory testing platform where people can log in there and they see a whole bunch of different testing options. The way that a company gets onto Rupa is by interest. And basically, people need to ask Rupa, say, hey, I would like to order said test. Do you carry it? And they'll say no. And then if they get enough people that are asking for a particular test, they will then carry it. So if y'all are interested in having any of Ethereum's offerings on Rupa, you'll just have to reach out to them and ask them. And if you're wondering why it's not, it's just because there hasn't been enough demand on Rupa itself. I don't know. Maybe people are going away from Rupa. I don't know. I'll use it on occasion, but then there's companies that'll just, go to their site and order it. So there's differences there. But anyway, I wanted to make everyone aware of that before I started. All right, everyone. So welcome to today's webinar. I will be covering nitric oxide and multiomics, and this is part two of a two-part series. My name is Dr. Greg Nacarelli. I am a naturopathic doctor and a PhD in genetics. I'm a precision health consultant and clinical success manager at Ethereum. And my goal is to combine natural medicine with omics technologies to improve precision and personalization of medicine. And so the outline for today, I will be covering different types of nitric oxides, health considerations of reactive nitrogen species, those being peroxynitrate, being nitrite being one of them, and then nitrotyrosine, which is an interesting one. I'll be talking about the NOX2 gene and its association with reactive nitrogen species, and two arginine metabolites, ADMA and SDMA, and then ways to protect against these things to balance reactive nitrogen species and to reduce aberrant nitric oxide. So I covered this last week. Just to briefly touch upon this, nitric oxide, it's nitrogen bound to oxygen. It's used to relax and widen blood vessels. It acts in the nervous system as a neurotransmitter. It acts as an immune signaling molecule. It assists with kidney electrolyte homeostasis. So this is the good one. There's nitrites. Now these are a food preservative used to cure meat, sodium nitrate, potassium nitrate. It's also used as a medicine for certain cardiovascular conditions. And it's also an antidote to cyanide poisoning. Then there's nitrates. These are present in air, soil, water, and foods like beets and lettuce and carrots and arugula. And these are the good things. We want these because these will act as a precursor for nitric oxide. As I mentioned last week, our microbiome will metabolize these. Now, the downside of this is it can contaminate groundwater, so that's another thing to worry about. And then there's the peroxynitrate. There's NO, which is a reactive nitrogen species. It's a reaction between nitric oxide and superoxide radicals. This is not good. This contributes to oxidative stress. It leads to protein oxidation, lipid peroxidation, protein nitration, which I'll talk about, enzyme inactivation, and it can trigger cell death. So some not good things there. One thing I wanted to keep in mind is that nitric oxide essentially opposes the actions of angiotensin. So if for the practitioners, it's probably like giving you PTSD flashbacks of the renin, angiotensin, aldosterone system. I know I had to memorize all the enzymes and intermediates, and lots of medications will target various parts of this pathway. But within this pathway is angiotensin 2. And so where nitric oxide is a vasodilator, angiotensin 2 is a vasoconstrictor. And so if you look at their mechanisms, they kind of have opposing mechanisms. You don't want to be too far off the end with either of them. So if you have way too much nitric oxide, your blood pressure is going to get too low, and that's not good. That's kind of an anaphylactic reaction. And then if you have too high angiotensin 2, that's why a lot of medications are trying to block this pathway because it's vasoconstricting the blood vessels too much. So you want this kind of in balance. And I think angiotensin 2 would be a whole other segue conversation that I could get into, and maybe I will in the future, but just something to keep in mind. Let a couple of people in the waiting room here. So nitric oxide, talk about all the good things about it. What happens if it's in excess or it's poorly cleared? It's associated with some not good things. Migraines notoriously are associated with nitric oxide dysfunction. Infections could lead to chronic nitric oxide upregulation, mold exposure, sunburn. It's where the erythema that's happening, nitric oxide is being released to recruit immune cells. And I'm not saying this is a bad thing. Your body's trying to clear things, but excess nitric oxide nonetheless. We have respiratory issues associated with excess nitric oxide, asthma, COPD, interstitial lung disease. And then, of course, low blood pressure. As I mentioned, too much nitric oxide, you're going to vasodilate, and then your blood pressure is going to be lower. So that's like the health conditions associated with it. Then there's the molecular consequences, which I'll get into in a little bit. And there's different types of cells that make nitric oxide. eNOS is typically in the immune system. nNOS, neuronal nitric oxide, typically in the brain. And then eNOS, endothelial nitric oxide, in the endothelium. Generally speaking, too much iNOS is the one that we're worried about when it comes to excess nitric oxide. So you've likely heard of ROS, reactive oxygen species, and you may or may not have heard of RNS, reactive nitrogen species. So with ROS, lots of different things can generate this. One thing I guess I would like to impress upon people, it's not just reactive oxygen species is always bad. Our body and our immune cells particularly, we have Kupffer cells and liver, hepatic stellate cells. Our body will use these things for purposes. So sometimes we want to generate ROS, and actually if we can't do that, that's also associated with bad things. But they could be increased from different enzymes, cytochrome P450 enzymes, the detox enzymes, NADPH oxidases, NOXs. I'm going to be talking about one of those in particular. So these are going to be generating ROS, and they're going to be having various effects on the body. In general, antioxidants and antioxidant response element genes, superoxide dismutases, catalases, glutathione peroxidases, etc. These will quench ROS. Reactive nitrogen species is the reactive is the key word here. So it's going to be reacting with things in our environment, and in excess, it's going to lead to damage. I mentioned iNOS being a not good one. When you have nitric oxides, those oxide part of it can make it reactive. It can bind to different things, forming peroxynitrate, which I'll talk about in a little bit. And then you could get these binding to proteins that we don't want. We don't want these reactive nitrogen species binding to proteins and malforming them. And that's where the damage can happen. Some things can help this. So autophagy will decrease for reactive nitrogen species. Unfolded protein response is going to affect it. Thioredoxin, the thio, that means a sulfur group. So this is going to help inhibit this. But there's lots of different types of reactive nitrogen species. And so I'll focus on a couple of those today. But either in excess is not good. So we have nitric oxide, superoxide radical binds, forming peroxynitrate. You will have particular amino acids that can bind to this, forming complexes. One famous one is 3-nitrotyrosine. This one has been associated with several not good things, impairing mitochondrial biogenesis, inhibiting cytochrome C oxidase, thus inhibiting aerobic respiration, inhibiting DNA repair. So some not good things there. The reactive nitrogen species can bind to sulfur groups. And so you could have these kind of weird intermediates here. You could have these nitrosothiol bonds or nitrothiol bonds. You also have, non-nitrogen reactive oxygen species. This is just ROS. And then these are reactive carbonyl species, which is where you could form these fatty acid lipid peroxidation products. Nacarelli, I'm going to leave it up to the chat if anyone knows a dietary source where this is found, a processed dietary source. I did my dissertation looking at aspects of this, but there's one particular common thing in the American diet where we are exposed to acrolein. It is an oxidized lipid that is not good. So if anyone can tell me where this is found, we'll check in the chat later. Peroxynitrate. So as I mentioned, this is a nitric oxide with a superoxide radical associated with not good things. When you look at health associations, we could actually look at, okay, when you have peroxynitrate and it's bound to these amino acids, what health associations is it associated with and what are the mechanisms? So it's associated with many. It's been found to be upregulated in ALS and Parkinson's disease, various neurodegenerative diseases in general, autoimmune diseases, rheumatoid arthritis, lupus. And you could see these particular modifications that are occurring, tyrosine nitration being one of the most common ones. You can see these other types of nitration as well. And so there's this damage that's accumulating that's predisposing these people for diseases. You can measure some metabolites with this. And so as a measure of DNA damage, you will see 8-nitroguanine being increased if there is these reactive nitrogen species binding to DNA. And so that's one that can be assessed as well. You can look down to the mechanism of where these are binding, and it's probably out of the context for clinical purposes. But if one was so interested, you could see exactly where on the target residues for specific compounds or proteins that these reactive nitrogen species are modifying these proteins, and then the impact on it, which is generally not a good thing. And you'll see this in various different pathophysiologies for different things. So it's going to interfere with biopterin-dependent enzymes. It's going to deplete antioxidants. It's going to increase lipid peroxidation, inhibit myocardial conatase, which is part of the respiratory chain glycolysis, TCA cycle. And so lots of different not so good things here that are occurring. And this is just looking at the cardiovascular health. Also diabetes, various different findings have been associated with increased peroxynitrate formation and increasing risk of insulin insensitivity, diabetes type 1 and type 2. So lots of not good things. Last week, I talked about nitric oxide synthase very briefly. It's going to help convert arginine to citrulline, and in the process, a nitric oxide is formed. And if you have oxide radicals in addition to this, it's going to bind to that nitric oxide to form peroxynitrate. And then if you have amino acids in the vicinity, it's going to nitrate them as well, forming various different compounds, one of them being 3-nitrotyrosine. So we could look at one metabolite and its association with disease. This study was looking at that metabolite in particular. They separated into quartiles, 1, 2, 3, and 4, 4 being the highest quartile. And essentially, given that, what is the odds of the disease risk, or how prevalent is it occurring in people with the highest amount versus the lowest amount? So, and you could look at here, this was coronary artery disease without peripheral artery disease, or then with it. Either way you slice it, the higher the nitrotyrosine, the higher the odds of these individuals having it, and sometimes many folds over. This is 6 times more. This one, 32.6 odds ratio, unadjusted, but even still, very high odds, or very high association of nitrotyrosine with cardiovascular disease risk. I should say, when I'm putting together these webinars, I first put them together, and then I kind of go back and speak with the chief scientific officer to let them know, hey, I came across these metabolites. Are we testing for these? Are we looking for these? And this particular metabolite, nitrotyrosine, is going to be added to our future Aristotle panel. It's not currently tested, but it will be tested in the future. So this is something you could potentially get tested through, at least through us. I don't know of another company that is offering that sort of testing, but I would love to get tested for it, because I obviously work with people with cardiovascular disease, and it would be nice to look at these metabolites to see what is occurring. In this way, we know that there's defects in the nitric oxide system, there's excess of oxidative stress, and it's leading to not good outcomes. Part of this is superoxide radicals being generated in excess, leading to nitric oxide becoming peroxynitrate. What is one reason this is happening? NADPH oxidase. So That's what NOx stands for. This is a protein complex that produces oxide radicals, typically in response to infections. Again, don't always think oxide radicals are bad. There's a balance. When it's in excess, it's not good. But when it's too little, this is where people can't clear infections at all. You want to be able to burst these organisms, and sometimes you just have to hit them with a lot of hydrogen peroxide or oxide radicals. And so you want to be able to produce it and then clear. That's the game. There are many different types of NOxes. NOx 1, NOx 2, NOx 3, 4. I think there's like 6 and 7. And they have different roles in the body. There are genetic variants that are associated with differences in NOx2 activity. Various differences can increase your susceptibility to either chronic bacterial or chronic fungal infections. In particular, chronic granulomatosis disease has been associated with different risk variants in the NOx gene. It's also a feed-forward mechanism, so the more it gets activated and then it produces superoxide radicals, it then kind of feeds forward and makes more and more, kind of run amok. As I mentioned, there's many different types of NOxes. Ultimately, they're going to be generating reactive oxygen species, which is going to increase vascular inflammation, oxidative stress in excess, which is going to lead to endothelial dysfunction and ultimately atherosclerosis. So this is one of those things. Doctors will assess for cardiovascular disease and just put people on a statin, and it's like, wait a minute, what's going on here? Is somebody have excess oxidative stress and inflammation from overactive NOx genes? And if that's the case, why is that happening and what to do about it? It's a different angle of approach. And so things like this need to be addressed, but they're associated with cardiovascular disease nonetheless. It's not always bad. So increasing superoxide anions will help with various pathways that will affect AMPK, which is generally considered a good thing to activate. By doing that, it will increase PGC1 alpha, which helps with mitochondrial biogenesis, HIF1 alpha, which will help with angiogenesis and erythropoiesis. It will decrease mTOR, which is associated with increasing autophagy, and then it will increase eNOS, which helps with vasodilation. So again, you want to balance, not too much, not too low. So what things can we actually do to help favorably impact this system? If you look at various studies, blueberries in general will have this modulating aspect on NOx enzymes. So blueberries, just simply incorporate that into the diet. Berberine has been shown to favorably impact this system. Berberine you could get as a supplement, or you get it with, I've actually had patients that just eat barberry to get their berberine. You can also get it in Hydrastis canadensis, which is very yellow. Berberine is a yellow pigment, so that one's good. Celestial Chinese thunder god vine, never tried it, but apparently it's a modulator of the NOx enzymes. Honochiol, if anyone has used Relora, which is a blend of magnolia and then phelodron. There's a ton of research on this compound. It's very beneficial. That wouldn't surprise me if there's many other mechanisms, but it does have a favorable impact on NOx enzymes. And then apocyanin from Canadian hemp, and then Picorrhiza corea. And that's what is actually from this study here is showing the modulating effects of apocyanin on NADPH oxidase, ultimately inhibiting ROS, which then has a favorable impact on the inflammasome, which will trigger inflammatory cascades. So things to consider to help modulate this if it is awry. I kind of already talked about this, but so you have NOx, superoxide radicals bind to nitric oxide, and then will lead to peroxide nitrate formation. So that's the thing that we're trying to avoid. So this is probably we're hitting the most complex part of this talk here. So eNOS uncoupling, nitric oxide versus ROS formation. Some things to consider. There's several players here. Okay, so we have biopterin. Where is that? Right here. NADPH here, and then CoQ10. These are necessary for eNOS coupling. So eNOS coupling is basically you have arginine, you make nitric oxide, and then citrulline is released. This in balance, you make nitric oxide, you're limiting the amount of ROS. So that's what you want. You don't want it to be uncoupled, because if that occurs, you're getting excess ROS formation. So when you have reduced eNOS activity, you're going to have arginine methylation converting into ADMA. So now we're getting into the ADMA conversation here. So here's acetylmethionine, methylating arginine, and then ADMA. This is going to actually inhibit this whole process. So I'm going to get into that in a little bit, but ADMA is going to mess up how our eNOS enzymes are functioning and ultimately increase the risk of cardiovascular disease. If we look at this pathway here, mevalonate, y'all remember statins will affect this pathway negatively. When you inhibit HMG-CoA reductase, you are inhibiting the production of these other compounds, geranyl pyrophosphate and farnesyl pyrophosphate. And these will also serve to upregulate eNOS activity. And so this is a double whammy here. Let's say you take somebody on a statin, they're inhibiting this part of the pathway, and let's say their methylation is messed up and they're forming more of this ADMA, which stands for asymmetric dimethylarginine. You're going to be leading to this uncoupling or malfunctioning, if you will, of the eNOS production. So there's lots of players in nitric oxide formation. It's not just arginine. You have to account for some of these other things as well. So SDMA, ADMA. SDMA stands for symmetric dimethyl arginine, and ADMA stands for asymmetric dimethyl arginine. These are biometrics of endothelial dysfunction. At high levels, they can inhibit nitric oxide via inhibiting nitric oxide synthase. ADMA is the worst one. So, and I guess the easiest way to think about it, asymmetric is worse than being symmetric. It's literally just where they're putting the methyl group on the arginine molecule. ADMA is a more potent inhibitor of NOS, and it has a stronger association with cardiovascular disease. SDMA, and I'm going to show it in a little bit, has a stronger association with kidney disease, and it mainly deals with this route of excretion. As you see here, 90% of SDMA is going to be excreted in renally. And then ADMA is going to have this interaction with DDAH, which is an enzyme, which I'll talk about in a little bit. These enzymes make them, PRMT1 and PRMT2. So I'll talk about those right now. PRMTs are a family of enzymes that add methyl groups to arginines, protein arginine methyltransferase. These function in DNA repair, the cell cycle progression, signal transduction, and transcription. There are several classes. Class 1, catalyze asymmetric dimethylation of arginine. Going back to this other, so here is PRMT1, asymmetric dimethyl arginine. And then class 2 does the symmetric dimethylation of arginine. These, when they're aberrantly expressed, are associated with not good things. They've mainly been studied in the context of cancer. So overexpression of PRMT is associated with cancer and chemo resistance. So there's actually oncotherapies that are targeting these enzymes in order to improve outcomes. And as I mentioned, here is the symmetric. Here's the methyl groups on the same side of the nitrogen. And then here's the asymmetric, where they're on different sides. And again, a methyl group is a carbon with 3 hydrogens binding to something. This is kind of illustrating what I just mentioned. So here we have our protein, we have our PRMT class 2, which makes these symmetric dimethyl arginines, and these go into, well, most of it, 90% is excreted renally, usually not a big impact on ROS production, and it's going to inhibit tubular L-arginine uptake, so that's actually not a good thing. So it's not good. It's not horrible compared to ADMA, but it's not good. Here's ADMA. Again, things that will upregulate these class of enzymes, and I'll talk about this a little more in depth here. Stress, cholesterol, ox-LDL is going to increase these PRMTs, which are going to make these ADMAs, which through this enzyme DDAH, it should clear it. It should convert ADMA into citrulline and dimethylamine. But this enzyme can be inhibited by various different things. It can be inhibited by cholesterol, high homocysteine, high glucose, various different viral infections, environmental toxins and exposures. So this is the main issue here with people not being able to clear ADMA. Is not so much up here, but it's that their body is getting inhibited. Also, ADMA is going to be an inhibitor of NOS. So it's like a double whammy. You take arginine, you asymmetrically dimethylate it, and then you prevent your body from making more nitric oxide. So this is how it's contributing to cardiovascular disease. If you've never seen this stuff before, maybe I could talk about it a little more slowly, go more in depth. This is, again, I've heard about some of these enzymes before, but this is a little new stuff. There's a lot of nuances with cardiovascular disease, and I think this is where we're getting into the weeds of some of these nuances. But nitric oxide is just not as simple as, hey, just take some arginine. There's other things to account for. So DDAH, okay, going back, it's this thing, which, again, you want it to be active to get rid of ADMA. This is dimethyl arginine dimethyl aminohydrolase. So you want that, but things that will inhibit this or downregulate this, proton pump inhibitors have been shown to actually block this enzyme. That was one of the most interesting things I found. So consequently, you'll see people on proton pump inhibitors will have higher ADMA. So this is where proton pump inhibitors have some of these other negative consequences that aren't good and could possibly increase cardiovascular disease risk. It's through blocking this enzyme. So that's not good. In general, elevated LDL, oxidized LDL is going to inhibit this. A diet poor in arginine is going to inhibit this. Low folate, high homocysteine, basically methylation dysfunction is going to mess this up. High oxidative stress, and those with hyperlipidemia, less enzyme activity. But if you remember one thing from today, just remember PPIs can inhibit this enzyme, which will increase ADMA because we're preventing it from being degraded. And then if that ADMA is going to inhibit NOS, which is going to decrease nitric oxide production. I don't think there's anything else I want to add. I mean, these are associated with inflammation, especially ADMA. So in addition to inhibiting NOS, it will increase NF-kappa B. So we're going to get increased inflammation from that, which is not good. And it looks like SDMA has some impacts on the immune system as well. Though again, not as bad as ADMA. There is a balance to these. So people have looked at the ratio of L-arginine to ADMA, and essentially, as we get older, that ratio decreases. So less arginine, more ADMA. So people have hypothesized, or researchers have hypothesized that this is associated with aging. And so this is one thing to consider. Yeah. It's not like one increases and the other doesn't. Generally speaking, if you have ADMA increasing, you will also see SDMA increasing. So there is a correlation there. It's not perfect, but they are correlated. So, there's something that to keep in mind. Usually, if the kidney is having issues clearing SDMA, there means there's vascular issues. And if there's vascular issues, likely there's ADMA contributing to those vascular issues. I already kind of mentioned these, but again, inhibitors of DDAH, oxidative stress, hyperhomocystinemia, insulin resistance, hypercholesterolemia, inflammation, not good. These can lead to obstructive sleep apnea, diabetes, hypertension, chronic kidney failure, congestive heart failure, which is going to lead to the increased formation of ADMA. So you see how people can get tangled in this web where it just gets worse and worse, and then their diseases are exacerbating. So this is kind of feed forward thing that's happening. You could look at many different diseases. I know I kept talking about it with cardiovascular disease, but it's been found increased in myocardial infarction, ADMA levels increase, congestive heart failures, very increased, atrial fibrillation increase, ischemic stroke. So various different cardiovascular markers, ADMA has been associated with its negative outcomes, not just health diseases, but other things in general. Let's see, there's a couple here. So they looked at BMI, systolic blood pressure, diastolic blood pressure, a little bit elevated in diastolic blood pressure, definitely in systolic as well. Two of them kind of shot off the charts. Okay, so I talked about nitration of DNA residues. This 8-OHDG is looking at basically DNA damage marker. Look at this shoot up in this fourth quartile of ADMA. So this p-value here, 0.001, high association. Basically, if you have elevated ADMA, it's very likely you're getting DNA damage. That's not good. Even though ADMA is not directly affecting the kidney, more so SDMA, usually if one is high, the other one's high. So you look at creatinine, these individuals, it's lower. So we're seeing a statistically significant association there. Albumin, statistically significant association, actually, yeah, pretty high, actually. So the higher the ADMA, our albumin is going to be affected. ACR, what are they saying this is? Oh, albumin to creatine ratio. Okay, got you. So there's a statistically significant association there. So it's associated with many different things. You don't want your ADMA to be high. This study was looking at obstructive sleep apnea. They looked at ADMA levels. They found that it was higher. Obstructive sleep apnea is one of those things I keep hearing more and more people talk about within the cardiovascular health field. It has to be considered when you have a patient come to you with cardiovascular disease, because this could be contributing to a lot of their issues, leading to oxidative stress, which leads to this peroxynitrate formation, which leads to the ADMA formation. So one thing to consider there. How do we lower ADMA? So you could look at studies of this. I looked at studies for this. So vegetable consumption inversely correlated with ADMA. More vegetables consumed, lower ADMA. Good. Tea consumption. The higher the tea consumption, lower ADMA. I'm sorry to say that, at least according to this study, actually, this was the same study that was looking at different foods and things that will affect ADMA levels, increased coffee consumption associated with higher levels of ADMA. Now, look, I think there's differences in how much coffee someone consuming and the sources of the coffee. Is there mycotoxins in it? Is there pesticides? Is there other oxidative things that are potentially leading to these things? So I think this is, there's also acrylamides in coffee. So I think how it's prepared and the purity of it is likely impacting this. But generally speaking, I usually recommend people to go with tea over coffee. It's just higher antioxidants. But I do think there's probably nuances in this as well. But let's just say your standard run-of-the-mill, not so good coffee being consumed in a BPA lined cup is probably not contributing favorably to ADMA levels. A single bout of exercise lowers ADMA levels, so just exercise will help it. Nutrients shown to lower ADMA, NAC, vitamin E, PQQ. I'm going to guess antioxidants in general can help this tremendously, but these have been shown in studies to lower it as well. Higher melatonin levels inversely correlated with ADMA. Likely if someone has higher melatonin, they're sleeping really well and they're not having this obstructive sleep apnea thing, their breathing is good, so that makes sense. And then medication shown to lower ADMA. So insulin resistance associated with ADMA. So makes sense. Metformin and I believe I spelled this wrong, rosylitazone, which is insulinometic medication, is going to have a favorable impact on ADMA. ACE inhibitors, there's medications. There's lots of herbs that are ACE inhibitors naturally. Something else to keep in mind. And then estrogen therapy lowers ADMA while lowering arginine. That's kind of an interesting one. It's odd that something decreases both. So something to keep in mind there. All right. I know I went on those tangents. I want to go back to nitric oxide as a compound because if it is in excess, there's some not good things with it. So magnesium has been shown to clear excess nitric oxide. Vitamin B6 helps modulate the response of nitric oxide. So if it's in excess, it helps balance it out. It's one of the ways that B6 has helped with migraines. It's helping to modulate this nitric oxide. If anyone has heard of feverfew, which is an herb, there's a compound in there called parenthalide. This has been shown to help modulate nitric oxide release. Feverfew is one of those herbs that people will recommend for migraines, and it's actually a really good herb. Somebody asked me during the question and answer a couple weeks ago, they said, how does methylene blue affect nitric oxide? Methylene blue is an inhibitor of guanylate cyclase. Now, guanylate cyclase is going to convert nitric oxide. It's going to activate cGMP and it's going to lead to vasodilation. So actually, methylene blue is going to inhibit this. So essentially, methylene blue is an inhibitor of nitric oxide via an inhibition of guanylate cyclase. So I thought that was interesting. Vinpocetine has a similar mechanism as well. And I'm going to talk about that in a second. So it decreases iNOS expression. And then agmatine, this is a neurotransmitter and it decreases nitric oxide by blocking nNOS. But it does have agmatine has a lot of mechanisms actually. It's I feel like it's kind of been hit or miss. It kind of irritates some people's guts sometimes. But I'm a huge fan of vinpocetine. If anyone has ever taken vinpocetine, this is from a plant called vinca, and it's so powerful. There was like, I don't know, I think it was like 10 years ago, people were worried that they were going to take it off the market because pharmaceutical companies were going to start marketing this as a drug, as an anti-Alzheimer's drug, because it had such a profound effect on cognition. It has an effect, so it's a phosphodiesterase inhibitor, so it's going to be working on cGMP, which is going to lead to anti-inflammatory properties. It's also an antioxidant as well, so it has this like modulation of neuronal NOS pathways in our brain, but then it also helps as an antioxidant. So that's like the mechanism. It really promotes clarity of mind. I feel like for people that don't have good cerebral blood perfusion, when you take vinpocetine, it really has a noticeable effect. So, and one of the ways it's doing it is by affecting nitric oxide pathways, but I'm a big fan of this. Also, somebody asked me a couple weeks ago about, or maybe I brought it up, but actually I meant to present the slide and it wasn't there. So nitrous oxide has an impact on nitric oxide, and it does so because nitrous oxide is going to deplete B12. As it depletes B12, you're going to see an increase in this methylmalonic-CoA because B12 is needed to convert it to succinyl-CoA. You'll see increased methylmalonic acid in people with nitrous oxide exposure. Why that is also not good is because this is going to disrupt our methylation cycle. So we have elevated homocysteine is going to be converted to methionine via MTR, and we need methylated B12 in order for this to happen. So nitrous oxide is just going to be messing up a bunch of things. But here's the mechanism that I briefly alluded to a couple of weeks ago. A lot of the information I took and presented today was from this review article titled Nitric Oxide and Peroxide Nitrite in Health and Disease. It is long, it is detailed, but it has a ton of good information. So if you wanted to kind of sink your teeth into these topics a little bit more, I highly recommend this article. All right. So in summary, I think we're done with the nitric oxide topic. Nitric oxide is very important in health and disease. If it's imbalanced, it's associated with cardiovascular disease risk, renal dysfunction, and migraines. We can measure particular metabolites to infer nitric oxide. Fundamentally, arginine and citrulline are important. Arginine is a precursor for nitric oxide. You could look at some when nitric oxide goes wrong. So 3-nitrotyrosine is a big one, ADMA, SDMA, and 8-nitroguanine as a DNA damage marker, or 8-OHDG is another DNA damage marker. Foods that will ways to increase nitric oxide are nitrate-rich foods. We talked about those last time. My favorite is arugula. It's the highest nitrate-containing food you could eat. Beets are another good one, Swiss chard. And then arginine and citrulline straight up. Take those to help increase nitric oxide production. And then ways to lower nitric oxide, or I don't want to say lower, but modulate it. Magnesium, B6, and feverfew. So I believe that's all I wanted to say regarding this. So, all right. That's it for the end of the nitric oxide talk. So I work for Therium. I do consults for Therium. We have a metabolomics test. And so if you are interested in meeting with me to discuss this or a test or just anything within the realm of multiomics in general, you can click on this link, which I or one of my colleagues will put into the chat. And with that, I will take questions. So thank you so much for attending. And I'm going to put this in the chat. So give me 1 second. I hope they didn't take vinpocetine off the market because I have some. I've been able to buy it. I don't think no, vinpocetine should still be available. Maybe it's not available on Amazon. Maybe it's been, you know, because I know Amazon at some point they'll take off some things randomly and then sometimes they don't come back. I read last night, I don't know if this is true, that ephedra was banned, but then it was unbanned. Then because manufacturers don't want to be liable, they just don't make it. So I don't know if it's actually still banned or if it's not and people just don't sell it anymore. I've actually never tried ephedra. If anyone has actually tried ephedra, please, I'm really curious what that was like. Apparently, it was quite an experience to die for. Sorry, I shouldn't say that. If you take too much of it, it is a sympathetic herb, very strong. And some people, unfortunately, took too much and they wound up having a heart issue and passing away. So it's a very powerful herb. And I think that's why they took it off the market. And occasionally, you'll have some things like that. Okay. Well, so it looks like some people can get ephedra. Yeah, it's good that people have it through practitioners because at least this way you know not to dose it too high. Okay, so acrolein is found in vegetable oil. Actually, it's when vegetable oil is heated. So particularly high omega-3 vegetable oils, or I shouldn't say omega-3, high linolenic acid vegetable oils. Acrolein is a lipid peroxidation byproduct that's found in oxidized vegetable oils, or I should say seed in vegetable oils. And so that's not good. Okay, so we have a comment here. Could you say more about hyperhomocystinemia and homocystinuria cases? What one can infer or expect to happen to them from what you shared today, and what things to mind when if we come across those patients other than methylcobalamin, methylfolate. I'm not sure is safe at high dose for all persons with these conditions. What assume they are all homozygous? So yeah, I mean, when we're getting to that, if somebody has hyperhomocystinemia, cystinemia, and then I think you said homocystinuria, which makes me, I don't know if you're alluding to that, it's higher in urine. They're experiencing methylation dysfunction, which is leading to an increase in homocysteine. And there's various reasons why homocysteine is not being broken down. First off, I suggest you go to the methylation webinar because I did cover this, I think it was in November of last year. Methylation pathways are very extensive. Homocysteine can go down several different routes. It could be with B12 and MTR, MTRR. It can be converted to methionine. It could also be converted into back into methionine with the help of trimethyl or betaine, excuse me. And so if that is not happening, so there could be a deficiency in methyl groups from that aspect. And then it could go down to cysteine or they call it the transsulfuration pathway with the help of B6. And so homocysteine has a couple options of where to go. When there's methylation deficiencies, it does not do that and it accumulates. Homocysteine itself can be damaging to the arteries. And then the factors that lead to excess homocysteine are also associated with detriments as well. So if someone has low methylated folate is used for other things in the body. So that could, there's other health issues that could happen there. If there's excessive inflammation, those enzymes could be impaired. If somebody has heavy metal exposure, it could inhibit some of those enzymes. Then obviously genetic variations. You mentioned MTHFR, C677T. There's various other genetic variants in the MTHFR gene that could impair its function. There's genetic variants in the other genes that are responsible for these pathways. And so I don't want to go too much in depth with those because I did cover that previously, although I could cover it again in a future webinar. But so there's a lot of those factors. So if that is all occurring, notice those enzymes that I talked about. There's several methyltransferases, especially the PRMTs. And so those methyltransferase, they're transferring methyl groups. If you have methylation issues, those enzymes are going to be impaired. Anytime you see methyltransferase, you have to think that we need sufficient methylation, or we need at least our methylation cycle to be working optimally. And we need to be able to produce methyl groups. We need to be able to get enough methyl donors in our diet. And yes, and we don't want factors that are inhibiting this. So that's kind of the thing that I would be thinking. And it's absent of the nitric oxide picture. If somebody has high elevated homocysteine, you want to lower it. If they have other signs of methylation dysfunction, you want to be able to target it. It's relevant to this, and it's tied to nitric oxide dysfunction. It's actually very much tied to nitric oxide dysfunction. But yes, so that's the extent I would mention that. Especially B12 too. If they have low B12, it's especially why they have low B12, especially if they're exposed to nitrous oxide, that's going to directly impair if they're exposed to nitrous oxide, it's going to directly impair nitric oxide. So you want to target those factors that are impacting that. So good question. We have another question here. Are there factors that can reverse damages from homocystinemia? Okay, I don't know if I want to cover because we're getting into the methylation talk here. But let me see if I could tie this in. Because I wonder how a practitioner could also factor nitric oxide therapies if it would play a key role in the physical recovery things. Yeah. Like if somebody comes to me, I mean, no one walks into your office and they're like, I'm a homocysteine patient or I'm a nitric oxide patient. They have other clinical issues, right? So you want to work through the issue, and then within that is the domains of dysfunction. So they could have nitric oxide dysfunction. Typically, it's lack of production of nitric oxide. But when you have more inflammatory issues with people with immune dysfunction, then it's in excess, which also pairs with the histamine as well. I feel like histamine, I feel like I probably should do a webinar. I could probably do several webinars on histamine, but histamine is also implicated in this as well. So that is also, things are also co-occurring within the context of a disease like an obstructive sleep apnea or cardiovascular disease. And same thing with the homocysteine. Your question is about reversing damage. When we're talking about damage, I guess, what is the definition of damage? Can you lower these metabolites? Absolutely. I think when you get to the realm of fibrosis, I think that's a different question. And so it becomes a question of what is the extent of damage. But you mentioned DNA damage, right? We could do interventions that if somebody has a high DNA damage markers and we intervene, we could see those things go down. And we have mechanisms in our body to clear DNA damage. There's genetic variants that impair the ability of that. I haven't mentioned this previously, but my family or within my family, my father's a carrier of a gene that impairs mismatch repair proteins. It's called Lynch syndrome. And these individuals have a genetic defect where they don't repair their DNA properly, which is associated with cancer. So, sometimes that there is impairments in DNA damage repair, but we could measure it to see how is given what somebody is doing. And there's lots of different supplements I like for this. There is cat's claw has these things called carboxy alkaloids, and they've been shown to increase DNA repair enzymes. So there's even some supplements, but I don't like to just go jump to supplements. Like someone's diet being rich in antioxidants and low in oxidative stress things like the acrolein I was mentioning. I mean, that's the foundation to reversing this or fixing this. So yeah, wasn't sure the size and extent of potential nitric oxide therapies could reverse things. The homocysteine damage was just one thing that came to mind. Gotcha. So okay, first off, I think if you correct methylation dysfunction, you probably will balance or at least attempt to balance nitric oxide. Actually, beets are a great example because beets are rich in betaine, which is going to help lower homocysteine, and they're rich in nitrates. I guess just eat beets. Just eat beets. That's my answer to your question. But yeah, for the relevance of nitric oxide testing strips, I bought them and I tried them. And I actually tried supplements which were higher in arginine before and after, and it did go up a little bit. So I think they're generally reliable. And I did cover this a couple webinars ago because then there's like you could measure nitric oxide on your breath. There's different like dilation tests. You could do a blood pressure cuff. So there's different ways to test for nitric oxide efficiency. But I would say it's a good measure of and response to supplements because you can see how you're responding to a supplement. These are just strips. Most I know there's several different companies that make them, but you just kind of dip it in your saliva and then you touch the applicator to the testing strip. And then within a couple seconds, it will let you know your level. It is non-specific. It's kind of like, is it high, medium, or low? So it's not like indicative or, excuse me, really specific by any stretch of the imagination. But I feel like I would trust it to let you know if you were low or high. So it's worth considering. So, all right. Okay. What are the key elements that exist in our bodies to prevent too much nitric oxide? Define key elements like minerals. Our body has a checks and balances. And so there are many different types of factors that are going to be eliciting a nitric oxide response. Like if I were to start jogging, my body's going to sense. So last webinar, we talked about hypoxia. Hypoxia is a trigger for nitric oxide because your body's like, oh shit, I'm not getting blood to my muscles. And now they're getting fatigued and lactic acid is accumulating. They're going to get damaged. I better send some nutrients that way. So the hypoxia will trigger angiogenesis factors to increase nitric oxide to get the blood where it needs to be. So that will happen. And so that's going to recruit nitric oxide. But so it's not like if you exercise too much, your nitric oxide will be too little. Well, actually, it can deplete you of arginine. There are covered a couple of webinars ago, genetic reasons why somebody has low arginine. So that will negatively impact it. You'll run through it if you're constantly using it. So you want to make sure you're getting enough arginine in your diet, I think, for sufficient nitric oxide. But within the context of nitric oxide, I'm thinking things that trigger inflammation. chronic infections, viral bacteria, or chronic environmental insults like someone keeps getting sunburned. I think these are the factors where there's too much nitric oxide. It's not being cleared. Our body, for whatever reason, it's not clearing an infection. It's not healing the skin or whatever. And this is what's leading to too much nitric oxide. There's also genetic reasons as well, especially within a case of migraines, there's genetic reasons. So there's that. And then what I covered today, it's not so much too much nitric oxide, but there's too much oxides that are turning the nitric oxide into peroxide nitrate, which is then leading to damage. So I'm actually more concerned about that. I think that's the more damaging thing, too much oxides. And I covered some of those factors earlier. But all right. Yep. Excellent questions, Michael. Thank you so much. So we're at the top of the hour. I am not sure when the next time I'm going to do another one of these webinars. If you value these webinars, please let Theriome know, and maybe I'll do more in the future. And if you have ideas for what you would like me to cover, I might cover viral infections and mitochondrial dysfunction. I would actually love to cover that because I think it's a huge topic. Yeah, I have a list of things I would like to cover, but we need you to ask for it. And if there's ways I could improve in this, please let me know. I'll try to keep it high level, practitioner, clinical relevant. All right, everyone. Thank you. Thank you so much, Michael. Thank you, Lee. Appreciate it. All right, everyone. You take care and you enjoy your weekend. Take care. Bye-bye.